Hello everyone, we come to experiment number 7a. This is a timer on chip. Straight away we'll go to the assembly language program. We'll deal with the different registers which we come across in this timer on chip program. We'll start with the first instruction. We'll go step by step with the instruction. So we have this clear CLR, clear port 1.5. So what it does is it will make the fifth pin of port 1 0. That is like rubbing it clean, like starting from a clean slate. This is the 40 pin diagram of the 8051, and we can see these 8 pins. We have selected this pin, port P 1.5, that one, and we will be seeing the output at this port pin. Going to the next instruction, we have move R6 14 decimal. Now to explain what this is, we have to go and see the calculation, the timing calculation for the delay of 1 second. So we have designed this program to give a delay of 1 second. I hope that you've already gone through the manual and you have tried to understand the calculation. I'll just breeze through this quickly. So we need the calculation, we need the delay of 1 second. So the maximum delay of the timer in mode 1 is equal to minimum delay into maximum count plus 1. So this is the formula which we use. So maximum delay of timer in mode 1, that is minimum delay we have already calculated, and that is 1.085 microsecond. To understand how we got this number 1.085 microsecond, we'll just take a digression and see how to get this calculation. So first we have to take the crystal oscillator and divide that by 12. So the timer frequency for the crystal oscillator frequency 11.0592 megahertz is crystal frequency divided by 12, which is, we have selected the crystal frequency of 11.0592 megahertz, that is into 10 raised to 6 divided by 12, which is 921.6 kilohertz. Now the time is the reciprocal of frequency, so the timer period will be 1 divided by f. If this is frequency f, so 1 divided by 921.6 into 10 raised to 3, that is kilohertz, is equal to 1.085 microseconds. So this is how we get the time, the time for one clock pulse of the timer. 1.085 microsecond is the tick time of the timer clock, or the period of one count of the timer. Continuing from the previous step, so we understood how we got this. When we multiply that, if you convert this into decimal, you get 655, and add it with 1, we get 65536 in decimal. So we get this. So this is the maximum delay of the timer. So that is the minimum delay into the number of counts plus 1, the maximum count plus 1. So that is, this is the maximum time delay of the counter. Now what is the count required if we want a delay of 1 second? To calculate that, we have to divide 1 second by the minimum delay. Now we know that the minimum delay is 1.085 microseconds. So divide 1 second by the minimum delay, you get number of counts, that is 9216589. Okay, but the maximum count for the timer in mode 1 is only 65536. So the timer has to repeat the cycle till we get this count. So how to do that? We have to put it in a loop and do that. How many times this number has to repeat, that we can calculate here. Number of times the timer cycle must repeat is the required count. So this is the required count, 9216589, the required count divided by the maximum count, which is 65536. So when we divide 9216589 by 65536, we get 14. You can see it there, it is 14. Going on to the next slide. Immediately we have to call the delay, a call delay. So from there the control will be shifted to the delay program there. Now we have to see what is a tmod register. The tmod register, we'll go and see what is a tmod register. The tmod register is a control register which allows us to make settings to use this register, use the 8051 as a counter, that is CO, or a timer. So the different bits, we can set these bits so that we can use it for our application. Now we want to use this as a 16-bit counter in mode 1. So for that the setting is the bit setting for each of these is given as below. So this is for timer 0. We are not going to use timer 1, so we make all the bits of that equal to 0. So this gate indicates that we are going to use this with the internal timer, so that is why we set it to 0. If it is 1, then we are going to accept external interrupt. Then we are going to use this as a timer. So for T0, if we want to use it in the timer mode, then we set it to 0. If we use it as a counter, we set it to 1. But since we are going to use it in the timer mode, we set it to 0. And here we are going to use it in mode 1. So M0 and M1 will be 1 and 0. So that is 0 1. So totally this tmod setting will be 0 1. This is a binary 0 0 0 0 0 0 0 1. In hexadecimal it will be 0 1. So now we understood why tmod we have selected it as 00000001 binary. B means binary. We are going to use mode 1, that is timer 0 in 16-bit. Next we go on to the next instruction, which is loading the TH0 and TL0 with the count. So TH0 and TL0 registers are the timer registers, and we are using timer 0. There are two timers, timer 0 and timer 1. We are going to use timer 0. So this is a 16-bit timer from D0. This is the low register TL0, and this is the higher register 8-bit TH0. So we're going to load both these with 0 0. TL0 will be 0 0 and TH0 will be 0 0. So the tip here you have to remember is lower the count in TL and TH, then larger the delay, because it takes longer time to count. For example, from if the maximum count is 10, then it takes a longer time to count from 0 to 10 than it takes to count from 5 to 10. So using that logic, 0 will give the full delay, the maximum delay. If you load the timer registers TL0 and TH0 with the minimum count, it gives maximum delay. Then we start the timer. Set bit means making that bit 1. So which bit are you making 1? We are making the timer 0 bit 1. So that is starting the timer. There's another way to set this bit. It is tcon.4. So here we'll see what is a tcon register. This is a tcon register. Pin number 4 is 0 1 2 3 4. So TR0 is this bit is used to start the timer. On reset it will be 0. So when we make it 1, the timer will start counting. When the timer starts counting, it will start counting, and then it comes here, and this is how the delay of the maximum delay of 71.16 milliseconds. It will wait till that time has elapsed. So when it reaches the maximum count, then TF0, that is, this will go back here, this bit will become 1. This is called the overflow flag for timer 0. TF0 and TR0 are for timer 0. So TR0 is used to start. When you make this 1, the timer starts. So when TF0, when it reaches a maximum count, overflow flag TF0 becomes 1. So how this instruction works is, jump on no bit TF0 here. So as long as it is counting, as long as the count is lesser than the maximum count, this bit will be 0. Since it is 0, since it is no bit, go back to here. So it will go on circulating here in this instruction until the maximum count is reached. This bit will become 1 and it will get out of the loop. So it comes to the next instruction. Clear TR0 means stopping the timer. TR0 will become 0 once again, and then clear TF0. TF0 here, when the maximum count was reached, it became 1. So now go ahead and make it 0 so that you can start the next, you can start the timer once again. Then return. So when you say return, it comes back here to this instruction. Decrement 14 to 13. Check if it is 0. If it is not 0, go back here to loop. And again this loop, this counting will continue for the next incursion of 71.16 milliseconds. So when you do this 14 times, a delay of 1 second will be achieved. Then it will complement. After doing this 14 times, it will come to this instruction, complement port 1.5. So initially we had made it 0, now it is made 1. So 0 to 1 transition will take place for after 1 second. After the next second, it will transition from 1 to 0. So each transition will be 1 second. So that we will be we'll show that in the form of a square wave on keel. I'll show you how that is executed. And then after that, after a delay of 1 second, S jump to main, it comes here again, reloads R6 with 14D, and it continues. So this is an infinite program where it will go on until you exit the program. Manually it will go on, giving you a transition of high to low, low to high on pin number 1.5 infinitely, and the transition, the time delay of each transition will be 1 second. We'll go over to keel and see how the program executes. So here we have the program. Save it. Once you debug it, view, analysis window, logic analyzer, and there you go to setup, and here you have a small box here. Click on that and you type the thing which you want to watch. We have selected port 1.5, so P1.5 and enter. So it will just become P1. Don't worry about that. Here select, clicking on this P1, select the maximum range. Here it is FF. You can make it 2 or 5 or whatever. Just make it 2 and 0. Minimum is 0 and 2. And then you can select a color if you want, whatever color. I've just selected green, and then close it. And then you have to tick these two boxes, signal info and show cycles. So you have to tick these two boxes, and then you have to run the program. So when you run the program, you see it will show a delay of 1 second here. Now how to see the delay of 1 second is, you can just zoom in, you can zoom in, zoom out, okay, zoom out, and then you can stop it and place your cursor on one end of the signal, click there, and then just mouse over the other end of the waveform, so at this end. So when you do that, you will see here, just mouse over. Now if you see the delta reading here, you can see the delta reading, and mouse over here, so you can see delta. So you have P1 time value mouse point, reference point, and delta. So there you can see it is 1.023517 seconds. So there you will see that it is the delay, that is the transition from 0 to 1 and 1 to 0. It is 1 second approximately. That is 0.9, it should be 1 hertz, 0.9 hertz. Okay, so this is how you generate a delay of 1 second and how to see the output. I hope you understood this. Try it out for yourself. I hope you enjoy doing this. Stay home, stay safe. I'll come back with another program. Thank you for watching. Bye bye.